Free response 1 on Spring 2015 Exam 1 is a pretty tricky integral to solve. So just looking at it, we have dx over square root of x, and that's all times in parentheses the cube root of x plus the fourth root of x. So that's a really, really weird looking integral. But it does have a solution, and I have seen problems like this come up on exams before, so it's a very, very good chance that one could always come up again. So you want to make sure that you know how to approach this style of problem. Now, she does give you a hint in this problem. It says begin with an appropriate u sub. So when I'm looking at something like this, I need to figure out some kind of u sub that I can plug in that'll compensate for everything. So I have a dx over square root of x and the cube root of x and fourth root of x. Now the secret lies in here. What I notice is that if there's a cube root of x and a fourth root of x, I need my u substitution to be something that is that I can apply some kind of mathematical operation to be able to get here. Now, the way I usually figure it out is if I have whatever these terms are, if I have x to the 1/4 and x to the 1/3, which is just another way of writing these terms, by multiplying these terms together, I can actually figure out the common denominator for them. So in this case, the common denominator for 1/4 and 1/3 is actually 1/12. So what I'm going to do is I'm going to start with a substitution that says u is equal to x to the 1/12. Now I can validate this by trying to get to x equals 1/4 and x equals 1/3 by squaring, cubing, taking it to the fourth power, whatever I need to do to be able to get there. So let's see if we can do that. So to get to a fourth power, I would need x to the 3/12, which means that if I cube both sides, I get x to the 3/12, which is equal to x to the 1/4, which is one of the terms that we need in that case. So u cubed will compensate for this term. Now, if I take u to a fourth power, that makes x equal, or u equal to x to the 4/12. 4/12 is 1/3. So u to the fourth is equal to x to the 1/3. Okay? So I've gotten these two terms down. The last thing I need, though, I need some way to compensate for this square root of x. And what I'm going to do is I'm going to use one of the techniques I did earlier where I'm going to get x by itself and then take its derivative. And I'm going to see if I can figure out where to go from there. Well, actually, in that case, that would compensate for the dx, but there's no way I can really get the square root of x. But I can by just taking this to a sixth power. This is u to the sixth is equal to x to the 1/2. And then if I raise it to u to the 12th, that's equal to x, because 12/12 is equal to 1. Then from there, I can get an expression for my dx by deriving both sides. Sorry, there's a du in here too. So 12u to the 11th times du is equal to dx. So now I have all the expressions I need to substitute in here for a u substitution. So let's go ahead and do that. My top part is 12u to the 11th du all over, I have u to the 6th, u to the 4th, plus u cubed. Okay, good. So I can keep doing a little bit of simplification here. I can pull out a u cubed from both of these terms, and I end up getting 12u to the 11th du over u to the 6th times u cubed is u to the 9th, and this would be times u plus 1. Okay, so now I can simplify some terms here. This becomes a u squared on top, and I'm left with a u plus 1 on the bottom. So I end up with the integral 12u squared du over u plus 1. Okay, well, now I kind of run into an issue that the power on top is higher than the power on bottom. When I encounter something like that, what I need to do is I need to long divide to resolve that out. So I'm going to long divide this term. U plus 1 into u squared. I'm going to treat this 12 like a constant, and I'll multiply through by 12 later on, once I get my expression for my long division. So u goes into u squared, u times 1 times u is equal to u. If I reverse the signs, if I subtract off, this becomes a minus. So these terms are 0, and I end up with a minus u. U goes into negative negative 1 time. That becomes a minus u. 1 times negative 1 is equal to negative 1. If I reverse the signs again, I get a positive 1. That term drops out. So my remainder in this case is positive 1. U can't go into 1 anymore, so what I can do is I can cap it there. I can say 1 over u plus 1 is my final term. So now, this expression is equal to u minus 1 plus 1 over u plus 1. So make sure you brush up on your long division before exam 1. That way, in case you do get a problem like this, you can resolve this out. So this is equal to 12 integral u minus 1 plus 1 over u plus 1 du. Now, all my terms are separated by minus signs and plus signs. So I can integrate them independently of one another. So when I go through and integrate this, I end up getting 12 all times u squared over 2 minus u plus natural log of u plus 1. That's all plus c. So now I've arrived at a final answer. All I have to do is I just have to plug back in for my u terms and get my original substitution. So when I go through and do that, I have 12 times 2, so that would be 6 for the first term. U squared, so if I square this term, I end up getting u squared equals x to the 1 over 6th. So that means my first term is going to be 6x to the 1 over 6th. Minus 12 times u is just equal to x to the 1/12, minus 12x to the 1/12. And then I have plus 12 natural log of x to the 1/12 plus 1. And then I write a plus c at the very end. So I end up with 6x to the 1 over 6 minus 12x to the 1/2. That's 1/12, sorry, thought that looked weird. 12x to the 1 over 12 plus 12 natural log of x to the 1/12 plus 1. And looking at the final answer key, that is a 6x to the 1 over 6 minus 12x to the 1 over 12 plus 12 natural log x to the 1/12 plus 1, all plus c at the very end. So I have arrived at the final answer for my free response.
The Teaching Center, UF's Learning Resource Center.